In this lesson, students will be able to multiply a single-digit number by a multiple of 10 using models and understand how that will help build their understanding of multiplication. You will remember in a previous lesson we learned how to model multiplication with base 10 blocks. For example, 2 times 10 is 2 rows of 10 blocks. We learned that when we have a number greater than 10, we can use rods instead of units to save time and be more accurate. So 2 times 20 is 2 rows of 20. I can represent 20 with 2 rods in each row. I can count by tens to find the answer, 40. Today we want to expand that understanding. We want students to see patterns and be able to make generalizations about when they multiply by 10. So let's go back to 2 times 20. What if we looked at a simpler fact? 2 times 2, which is 2 rows of 2. What is different from 2 times 2 to 2 times 20? 2 times 2 is 4, and 2 times 20 is 40. Do you see anything that is similar about those arrays? These are questions that you will want to ask your student as you help them work through this problem. Let's look at another example. 2 times 50. To make a different connection and look for patterns, let's first look at 2 times 5. 2 times 5 is 2 rows of 5, which equals 10. Now let's create 2 times 50, which is 2 rows of 50 each. What is different about 2 times 50 compared with 2 times 5? You'll notice that I still have 5 objects in the 2 times 50. The difference is that I have used tens or rods instead of the ones pieces. One more example. Let's look at 5 times 3 compared with 5 times 30. 5 times 3 would be 5 rows of 3. Now we know that 5 times 3 is 15. What would 5 times 30 look like? Well, it would be 5 rows with 30 in each row using the rods for each piece. You're going to want to ask your student again to notice if there are any connections and patterns between the simpler math fact of 3 times 5 and the multiple of 10. You want them to recognize that multiplying numbers like 5 times 30 is the same as multiplying 5 times 3 multiplied by 10. You'll want to avoid the common pitfall of having them learn you just add a 0 to the number because there is a 0 in the problem. This is inaccurate and will cause problems as early as 5th grade when students begin to multiply decimals. 3.5 times 10 is not 3.50. We want students to look for patterns and create mathematically sound generalizations that will help them throughout their mathematics, rather than create confusion because a rule they invented in 3rd grade no longer works in 5th grade. To review, we multiplied a single-digit number by a multiple of 10 using base 10 blocks as models. We connected a simpler math fact to the multiple of 10 to help students make a generalization or rule about multiplying by multiples of 10.